Hello students, this is Mr. Damiani, and today we are going to be looking at lesson 9.1 on page 491 in your workbook. The topic for today's lesson is independent and dependent variables. The central question, how can you write an equation to represent the relationship between an independent variable and a dependent variable? So the equations that we are going to write with lesson 9.1, and you're going to see a lot throughout chapter 9, we'll have two variables. All right, and this is going to be very similar to what question 15 has looked like on the Mountain Math board. So if you think back to what question 15 has looked like over the last few weeks, where you have two variables in a chart, that's really what we're going to be doing, representing an equation that has two variables. Please follow along as I read. You can use an equation with two variables to represent a relationship between two quantities. All right, so what I'd like to underline there is the fact that we are going to be looking at a relationship between two quantities, and these will usually be unknown quantities. Therefore, you would need two variables. One variable is called the independent variable, and the other is called the dependent variable. The value of the independent variable determines the value of the dependent variable. Now go ahead and underline that because that's going to be very important to understand the difference between the independent and the dependent variable. One thing to remember is this dependent variable always depends on the independent. All right. So that's one of the biggest things when you're trying to identify your independent versus your dependent variable. Your dependent variable will always depend on whatever that independent variable is. All right, so two key pieces of vocabulary that you need to be able to understand as we work through lesson 9.1. All right, let's go ahead and scroll down and we're going to take a look at the unlock the problem. Please follow along as I read. Jerry burns 5.8 calories for every minute she jogs. Identify the independent and dependent variables in this situation. Then write an equation to represent the relationship between the number of minutes Jerry jogs and the total number of calories. All right, now I'm going to read that one more time, and this time I'm going to code it up and underline the key pieces of information. Jerry burns 5.8 calories for every minute. So that is the relationship of how many calories she burns per 1 minute. Identify the independent and dependent variables in this situation. So I have to identify the independent and dependent variables. Then write an equation to represent the relationship between. So I'm going to write an equation to represent the relationship between the number of minutes Jerry jogs and the total number of calories she burns. These are our two unknowns. Okay, so these are our unknowns. That means if they are unknown, then we will need a variable. Okay, so those are the two things we're going to need variables for. We don't know the number of minutes Jerry jogs. That's going to change depending on the day. And the calories will change because that's going to depend on how many minutes Jerry actually decides to jog. All right, so looking over here, please. Why do we need to use a variable? We use variables to represent unknown quantities. So represent an unknown value. Fill that in there. How many variables are needed to write the equation for this problem? Well, we identified that we had two unknowns, so we're going to have two variables. All right, let's start breaking this down now. Identify the independent and dependent variables, then use the variables to write the equation. All right, so we're going to identify what our variables actually represent in this problem. So we're going to let C represents the total number of calories that Jerry burns. We chose a C because calories starts with a C. We're going to let M represent the other unknown, which would be the total minutes that Jerry decides to jog. Obviously, you're choosing M there because of minutes. All right, so we now have our variables selected. We're going to use a C and an M in our equation. So let's go ahead and scroll down now. So we're going to think to ourselves, the total number of calories Jerry burns depends on the number of minutes she jogs. So the calories depends on how far you're going to jog. The further you jog, the more calories you burn. If you jog for 5 minutes or 15 minutes, that's going to change the amount of calories that you burn. So we're going to say that the amount of calories, C, is our dependent variable. And we're going to say that M, the number of minutes, is the independent, because as M changes, that changes the amount of calories we have. Now, one thing I want you to make a note of here on the side, when you write your equation, you're always going to write the equation starting with the dependent variable. So your dependent variable will always be first, and you will always set that equal to whatever the relationship is with your independent. All right, so that is your relationship with your independent. All right, so let's write an equation to represent the situation. The total number of calories, C, is equal to, the relationship was 5.8 calories per minute, so that's 5.8 times the number of minutes jogged. So the equation C is equal to 5.8 M. The total calories is equal to 5.8 times the number of minutes that she decides to jog. Represents the number of calories C she burns if she jogs M minutes, where C is the dependent variable and M is the independent variable. All right, so let's go ahead and turn the page. We're going to look at another example on page 492. Please follow along while I read the problem here. Laura Lee is spending the afternoon bowling with her friends. Each game she plays costs $3.25, and there is a one-time shoe rental fee of $2.50. So let's go ahead and read that one more time and mark it up. Laura Lee is spending the afternoon bowling with her friends. Don't really need to underline anything there. Each game she plays costs $3.25, and there is a one-time shoe rental fee, $2.50. I just went bowling last week with my kids, and this is something that we had to work out. How much is it per game? And then, we have to rent shoes because we don't own our own bowling shoes. So this is a real life situation. Part A, identify the independent and dependent variables in this situation. Then write an equation to represent the relationship between the number of games and the total cost. So what I'd like to underline now is the number of games and the total cost. These are our two unknown values that we will need variables for. The number of games will change depending on who's bowling. And then therefore, if the games change, then that total cost will change. So in this situation, the total cost in dollars, C, depends on the number of games she decides to play. So we would say that C would represent the cost, and the games, we could use a G to represent the games. All right, so the amount of games changes the cost of the bowling experience. Okay, so think. The total cost is represented by C equal to 3.25. Now that's $3.25 per game. That's the cost of a game, times the number of games you decide to bowl, G, plus there is that one-time shoe rental fee up here of $2.50. So no matter what, whether you bowl 1 game or 10 games, you pay $2.50 for your shoes. All right, let's go ahead and scroll down here. So to wrap this up here for part A, so the equation C, my dependent variable, equals 3.25 G plus that $2.50. This represents the total cost in dollars C that Laura Lee spends if she bowls games where, going through our variable list now, C is the dependent variable and G is the independent variable. Okay. Now that was part A. Part A was generating that equation. Part B says, use your equation now to find the total cost if she plays 3 games. So what if G equals 3? Now we're going to go through and we're going to substitute into our original equation, finalize an answer. So we write our equation, which we have here for you. We're going to substitute in. I'm going to replace G with 3 plus the 250. And order of operations says, hey, take care of that multiplication step first. So we have $3.25 times 3 is going to give us a total of $9.75 for the games themselves, plus that $250 rental fee for the sneakers or the bowling shoes. And that's going to give us a total of $12.25. So it will cost Laura Lee $12.75, or sorry, $12.25 to play 3 games and rent shoes. All right, let's go ahead and turn the page to the share and show. It's going to be located on page 493 here. And I'm going to do an example with you. I'm going to let you do a couple on your own. And we'll check them up and practice this in class on Monday. So directions say identify the independent and dependent variables. So we know we have to first identify our 2 variables of the unknowns. Then write an equation to represent the relationship between them. Remember, when you write your equation, you always start with your dependent variable first. So it'll always be your dependent variable equals whatever that relationship is with the independent variable. So question 1 here. I'm going to read it through one time and then I'm going to mark it up the second time. An online store lets customers have their name printed on any item they buy. The total cost C in dollars is the price of the item P in dollars plus $3.99 for the name. All right, let's read it one more time and we'll mark it up. An online store lets customers have their name printed on any item they buy. Do not need to mark anything up there. The total cost C in dollars is the price of the item P in dollars plus $3.99 for the name. So this tells me what I need to really know from the problem. I have 2 unknowns here. I have the total cost, which we don't know, and I have the item, how many items you're going to buy, or what item you're going to buy, and the price of that item. So that's going to also be an unknown. The one thing that is not an unknown is the fact that you have to pay $3.99 for the name. So the total cost depends on the price of the item. The dependent variable in this situation is going to be the total cost because that's going to change based on the item price. My equation, like I said, is going to start with my independent, my dependent, misspoke there. And the relationship with my independent is the items plus that $3.99. Oh, make those 9s. There you go. And that is our equation. What I'd like you to do now is go ahead and pause the video, and I'd like you to go through and answer question 2 and 3 on your own, restart it, and I'll go over those answers for you. All right, thank you for go ahead and pausing that video. The dependent variable for number 2 was represented by B in this case. And sorry, that should not be a B, that should be, since the total distance D in miles. I'm gonna make that, my answer key has a B there. So the total distance D is your dependent, and then the independent there is the amount of hours. The equation would be the distance equals 6 times the amount of hours. And over here for number 3, the dependent variable was the T for the pounds, and the M, oh, sorry, I was looking at the wrong one. My fault. We're getting near the end here. C here and P here for C equals 199 P. All right, so that takes care of questions 3 and 4. The independent question I'd like you to work on for your homework tonight would be question 4. So have that done, ready to go. Remember to have a post-it note with the main idea for my students. And as always, if you have any questions, please get those on a post-it note as well. So thanks for taking the time to watch the video. We'll work on this on Monday, and I hope you all have a great weekend. Bye.